Hello students, new chapter will be started today onwards is acids, bases and salts. In today's class, we take introduction to acids, bases and the salts. Definitions we see acid it has many definitions, but most widely popular definition we are going to learn. So here we have two definitions. They are very popular. Number one, compound formed by dissolving non-metallic oxide in water. So a non-metallic oxide like sulfur dioxide. Here it is an oxide, but sulfur is a non-metal, so it is called a non-metallic oxide. Similarly, carbon dioxide, phosphorus trioxide, or even phosphorus pentoxide, anyone, and nitrogen dioxide. Nitrogen has many oxides. Let's see nitrogen dioxide. So these are all various non-metallic oxides. When these non-metallic oxides dissolve in water, we are going to get the compounds whatever they are called acids. For example, sulfur dioxide in water gives H2SO3. We call that sulfurous acid. Similarly, carbon dioxide will form H2CO3 called carbonic acid. Phosphorus pentoxide H2O, we get phosphoric acid. Nitrogen, nitrous acid. Like this, various acids we are going to get by this. There is another definition for it. The second definition for acids is a compound with replaceable hydrogens. A compound with replaceable hydrogens. When you observe the above formulas, each and every formula will start with hydrogen. Means acids surely going to have hydrogens. So these hydrogens when are replaceable, and that means when these hydrogens can be displaced by any other material, those hydrogens are called replaceable hydrogens. So existence of these replaceable hydrogens also make it an acid. Now base. So how are we going to define? Same as the first ever definition is a compound formed by dissolving metallic oxides in water. So this time we take metallic oxides like sodium oxide, magnesium oxide, calcium oxide, zinc oxide. So the oxides same we here having here, but these are formed by metals: sodium, magnesium, calcium, zinc. These are all metals have formed oxides. So this time the dilution in water will produce that is the new compounds. Those are called as bases. Sodium hydroxide, magnesium with water will give us magnesium hydroxide. Calcium will give us calcium hydroxide. Zinc produce zinc hydroxide. These are all bases. The second definition for the bases is a compound with replaceable hydroxides. Replaceable hydroxides. Hydroxides are none other than OH. These are hydroxides. These are replaceable. We can call them as bases. Okay. So these are popular definitions. Okay. And this is introductory about acids and bases. When we search about their properties, the properties of acids, bases are explained like this. In physical properties, we have some information about it. Acid physical properties, when we see, here I will write the properties. Acids properties: sour in taste, concentric. These are very concentric and cause severe burns when fall on our skin. These acids fall on our skin. These are highly capable or interested of absorbing water. So these acids have an ability of absorbing water or moisture. So when these fall on our body, the moisture present in our body is immediately absorbed by these acids. This is what we call severe skin burns. Okay, and this information about the properties of bases we see. The bases are bitter in taste. These are also concentric. That means these also can cause severe burns, and these are soapy natured materials. Okay, physical properties. And regarding the chemical reactions, when we speak, acids can involve in chemical reactions of many compounds, where bases are very few. When chemical properties we discuss, the main chemical property is neutralization. Means it is a reaction between acid and a base. When acid and base react with each other, they are going to produce salt along with water. So we are going to get salt and water as a product. So for example, an acid, we take hydrochloric acid, a base, sodium hydroxide. So when the chemical reactions takes place between them, the product will be sodium chloride, a salt, and as expected, water. So this is neutralization reaction. Okay, so we don't stop here because neutralization means not only between acid and base, even the chemical reaction between acid and basic oxides or acidic oxides and bases. Acidic oxides and bases is also neutralization. Here also we get the results: salt, water, salt and water. So example reaction, see, acid and basic oxide HCl and Na2O. This releases same sodium chloride and water. So not only that, so carbon dioxide and sodium hydroxide. This brings a result of sodium carbonate and water. So this is the chemical reaction that can be observed by neutralization reaction. Along with that, the acids can also involve in chemical reaction with salts. When these chemically react with the salts, the type of acid will be transformed into another kind of acid. For example, when hydrochloric acid reacts with sodium sulfate, so what's going to happen here is the sodium will be replaced. That means sodium will replace the place of hydrogen. So sodium sulfate will become sodium chloride. Along with that we get hydrogen sulfate. That means we can call this sulfuric acid. So the transformation of acids takes when the reaction with the salts is observed. So the chemical reaction with the salts will produce transformation of acids. Next, with the metals, it is very important reaction. Acids with the metals will produce acids with the metal will produce an imported gas. The gas name is hydrogen. So in acids, the chemical reaction with the metals will produce hydrogen gas. The hydrogen gas will be the main product of this reaction. Along with that, we also see the chemical reaction with carbonates, bicarbonates. So here, no need of much explanation. All we need is what's the major product here? It is carbon dioxide. Remember, any compound when involves in chemical reaction with the carbonates or bicarbonates, surely this carbon dioxide will be the product. So we must remember that carbonates and bicarbonates release carbon dioxide gas, metals release hydrogen gas, salt chemical reaction will displace the acids, transform the acids, and the remaining produce salt and water. Okay, so these are the properties of acids. Now let us follow bases properties. You see, bases usually involve in only neutralization, will not react with any metals, but in some extreme conditions sodium hydroxide involve in chemical reaction with zinc, and this chemical reaction will produce a compound called as sodium zincate. This compound name is sodium zincate, along with water. So this is the only chemical reaction that can be produced by a base sodium hydroxide with a metal zinc. Okay, these are the properties of metals and non-metals. Okay, now when we get into the lesson, how to recognize a substance acidic or basic. To determine that, we use some materials which are called indicators. Indicators are the materials which determine a substance whether it is acid or base. So what are the indicators? Mainly we have 1, 2, 3 type of indicators, and recently we have got a fourth indicator. So what are those? Type 1, natural indicator. Type 1 is natural indicator, so naturally existing indicator. Type 2, laboratory indicator. So laboratory indicators, chemical indicators with some kind of chemical compositions, these indicators are formed. Next, olfactory indicators means smelling indicators. By the nature of the smell, these can determine a substance is acid or base. And the last one is universal indicator. This is the mixture of various laboratory indicators. So more than one kind of indicators are mixed with each other. They are going to form a universal indicators. So universal indicators. Next, so these are the 4 types of indicators. Let us take the example. For natural indicators, turmeric powder that we can have usually in our house, vanilla essence, these are natural indicators. And laboratory indicators, most of them we know. Litmus, it is available in 2 colors, blue and red. Next, methyl orange. Next, phenolphthalein indicators. Next, for olfactory indicators, smelling indicators, onions. Onions are very good and effective to determine whether it is acidic or basic using the smell of materials. So onions are olfactory indicators. Next, universal indicator. Universal indicator is already explained, a mixture of various chemicals present. The difference of universal indicator with others is the other indicators like natural, laboratory, olfactory indicators determine whether the substance is acidic or basic. Acidic substance or basic substance, only they can determine. But universal indicator has an ability to determine that the substance, whether it is a strong or weak, that means the strength of acidic basic nature also can be determined by universal indicators. So when universal indicator is used, we can determine the strength also. Okay, but as per our syllabus, we need to remember what are the changes can be produced by acidic substances and basic substances by the laboratory indicators like litmus, methyl orange and phenolphthalein. By using these three, what changes in the color of the materials we get? Let us see. In a table we make it. Observe this table. This table has been asked for SA1, the last academic year. But many people did not understand how to draw it. First, see your number. So indicators we take. We have 4 indicators. Blue litmus. So litmus is 2 types. So blue litmus, red litmus, methyl orange, and finally phenolphthalein. So what are the results? First in acids and next in bases. See, and also we have a need to remember change in salts. Acids. In a presence of acids, blue litmus will give a change by changing its color to red. But red litmus paper will not give any change. But where methyl orange changes once again into red color in the presence of acids, phenolphthalein has no color. Phenolphthalein indicator has no color in acids. Now with respect to bases, blue litmus paper will not have any change, but red litmus changes to blue. No change in bases, blue litmus paper. Red litmus paper changes to blue color. Now what about methyl orange? Methyl orange will change its color to yellow in bases, and in phenolphthalein indicator it will change to pink. And as usual, all salts have no change in the indicators. salts have no change in any indicator. So when a substance responds to any indicator, it is definitely either acidic material or basic material. But no response from any material by any kind of indicator, it is non-acidic. Non-basic means we can expect it salt. Okay, so these are the changes can be produced by the salts, acids and bases with respect to various indicators. Okay, that's today's introductory part. In the next class we are going to learn the pH and pH scale and how to determine exactly a substance is acidic or basic, and also classification of acids bases also will learn. And repeat this you once they watch this video and make some notes to get some introduction to acids and bases.